Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Spacex Starship IFT-7. I know it's late, I was in Delhi, so I do apologize. So this puppy, IFT-7, now this supposed to happen on 16th, actually it's supposed to happen way before that, but it happened on 16th January 2025, 22:37 Universal Time Coordinate, or in Indian time it was 4 a.m. so to say. And this puppy was Block 1, booster number 14, Block 2, ship number 33. Now that was the biggest change. The ship actually went through a giant change log where it's no longer wise enough to say, oh, it's just some updates. No, it fundamentally redesigned. So it was Block 2 variant. To give you a context, Falcon 9 is on their 5th variant right now, Block 5. So block jump is generally a very big jump. Even though they are doing continuous modification in every launch, block jump is meaning blank slate. Everything starts fresh from all the learnings, and then you're like, okay, now let's redo it. So it was a big jump, and they were targeting booster recovery because, again, while they did manage to recover on 5th, it was not a very smooth experience. It only also caught on fire, had some parts falling off, not a really good idea. 6th one, they had a radio handshake failure, so it's like, this time they're like, let's make sure that we can actually land the booster, otherwise it's like they were lucky. So booster recovery, priority, payload deployment. Now this is the most critical part. You have to understand, while Starship can do everything under the sun, it can't really do anything right now other than one core fact. It can deploy Starlink, everything. It's payload door. It's not like a launch vehicle like New Glenn. New Glenn is a launch vehicle first. Starship is a Starlink launcher first. Then they have to figure out, okay, how the heck we're gonna have payload fairing. And because, again, the heat shields comes so backwards, the door mechanism would be very complex, and how they're going to deploy from that door, almost like a cave-like structure, how the heck they're going to deploy from there, it's going to be tedious. So they have not sorted that part out. So payload deployment was only there to simulate what it would be like to launch a Starlink payload. So payload was a dummy weight of same size, same dimensions as Starlink, but it was not a real satellite. So payload deployment. Now, if this would have worked, that would have at least taken some edge off from the financial burden of the program, because Starlink launches, once they start to deploy the really big puppies, it will really start printing money. But so far, they are hoping and waiting. So payload deployment test was very important. Engine relight in space, that should have been super easy. They have managed to do it. So that's a good part. Re-entry, again, they have some good experience with re-entry and recovery. So that was the aim. And massive changes. Let that be very clear. This is like completely different. So whenever you are seeing block numbers, that simply means they are taking the constraint. Okay, let's say this is the diameter, this is the height, that's the cylinder volume. Okay, that's it. Now design everything from the past learning experience. It's like, okay, do not just modify the hinge, throw away the hinge. Where do you put it? Okay, now you put a smaller canard. So that's why we call it block variants. Booster is almost like a slow and steady progress, and booster has made significant progress in terms of reliability. Booster is not one of those things where it's like, oops. Booster is like, me good. So this is IFT-7. Now, takeoff supposed to happen on 13 January, and then they detected some sort of oops event, and that oops event caused a 2-day postmortem. And after that, then 15th, they tried to do it, and again, unfavorable launch window, and then they had to delay it. Unfortunately, I wrote 15th here. They did it on 16th, and finally took off without any issue. And I have to say, please pay attention from the next launch. They are increasing its speed almost every launch. Basically, it almost looks like yeet cannon out of the air. And you can check, like, how can you verify, right? The telemetry refreshes quite accurately into the bottom right, and you have a clock there, T plus 1 minute, T plus 2 minutes. Like, this puppy is getting fast. It's like, this puppy is getting fast. Like, I remember launch number 1, where it's like, this launch is like, this puppy is getting fast. So takeoff was very smooth, very fast, horrifyingly fast, but that part is sorted. Then we had come to the booster catch part. Now, let that be very clear. This is why booster catch is such a smart thing. While from engineering point of view, from science point of view, this is a dumb idea. Because, again, the propellant they are keeping just to do this, it would be far more beneficial to use that to push second stage. And that's why their second stage is so huge, because again, this is wasteful from rocket equation point of view. That's scientifically truth. Then why they are doing it? Well, they have understanding that physics, engineering, economics is the daddy issue. And I did try to cover the launch of New Glenn, and again, New Glenn exposed this perfectly. They were ready. The rocket was fueled. They're ready to go. Everybody is fine. They had to scrub the launch. Why? The landing site, basically where they had the barge, weather was unfavorable. When you are doing this, basically catching exactly where you are covering, you only have to worry about one weather area, not two. That is significant. And remember, money does not buy time, it only buys speed. This takes a lot of money, again, wastes a lot of propellant, but gives you speed that nobody else can compete with. You launch your rocket comes back 10 minutes later. Done. Go home. Done. 10 minutes, sir. Either it worked or it did not work. There is no if, else, or it bad C, nothing. 10 minutes. Take it and go. So that's why this idea is so clever in terms of economics. It's a bad idea from rocket science. It's like, rocket engineers like, what are you doing, my man? You are throwing away so much propellant. They're like, I got you, fam. We're just going to make it bigger. So first attempt worked, but it did catch on fire, and it did had a lot of parts falling away. So injured, let's just say injured. Second, the radio handshake, basically this puppy and this puppy did not made love, and the handshake failed, and they are like, okay, let's play it safe and yeet it into the ocean. And third time they worked flawlessly, meaning now they have double redundancy radio lovemaking. So they're like, no, this puppy is going to work, because be mindful, you're talking about a skyscraper moving on things that are size of buses. It's like, yeah. This has to be precise AF. So they had to make sure that things work, and this proves that their booster design is almost ready to go. They only have to redo it once, simply because they have not designed it properly where they can have that ring. They just designed. You can't have a reusable booster if you're eating the ring every time. So they have to upgrade it. Now, can they do it? Well, yes. Because again, the engines are outdated in this. They are already working on Mark IV variant of the engine. So if the engine progression is as expected, they can easily add the weight and they can just push through it, because again, the thrust is so high. And that's why I keep talking about the acceleration is very fast. They're pushing through. They're pushing through the gravitational losses very efficiently. They're just like, let's go. So booster, I can easily expect 2 or 3 launches more on this design, and then they're gonna go to block 2, and they'll be like, okay, done. They can stop with booster messing up at that point in time. They're like, dude, it's good, it's ready. Let's divert all the attention on other things, like making Starship actually deploy things other than Starlink, so they can make money back, or like, do the lunar thing and all that jazz, and other stuff. So booster, they can stop development wise. Maybe 2-3 launches, they should go to a Mark II variant or Block 2. So booster, good. Now Starship went oops. So the boom event here was a very serious event. Now the signs were there, like this is a launch event at a T plus 1 minute 2 seconds. You can see starting a flap starting, and this is before max Q. Now this could be a small nothing burger to, oh, this was the early signs of overpressure event. And be mindful, before max Q, if you have a flap going there, once you start to have supersonic wind going through there, things could cause damage. So that was there. Now the moment they're starting to reach almost, this is so painful part of this, it almost reached where it's supposed to go in terms of their test orbit, almost reached it. Only a few seconds they needed the full engine thrust. They would have been like, bro, we got this. But engine started to cut off one after another. One, it's like, oops, computer's like, okay, let's redivert it. This, like, then that engine poofed up. It's like, okay, let's start it out. Then other poofed up, then telemetry goes poof, and then this boom event happens. So they can literally see computer working its ass off to save the system, and then it's like, yeah, I cannot do anything, and then it's like telemetry is like, I'm out. So after that, this happens, boom. So most likely, as of now, the leak happened. Something, and that's why I'm saying, like, this break, it could cause the leak, especially if it was going through max Q and very high pressure air went inside. That could cause some minor issue, which again, with the launch vibration and engine firing and all that, could develop into a leak. Fire, again, it is visible in certain shots, and then overpressure, poof. Now this is another aspect, because the Starship, again, same thing, it keeps propellant to itself. There is certain tanks they're keeping fully loaded for re-entry burn and re-entry landing catch. Yeah, that also means no matter what you do, even after launch, if it goes boom, it has more than enough propellant to actually cause a big boom event. And that's what you see, the very big boom. Even if the main tank and hydrogen, I'm saying, methane and oxygen tank were fully depleted, the header tanks would have more than enough to cause this sort of catastrophic failure. And this is bad. Now, to give you a context, we have, unfortunately, a space shuttle breaking up like this. And if you compare them side by side, then you will actually realize how huge this thing is. This is not a small thing. And be mindful, generally we use lithium aluminum alloys, and those puppies are not strong in terms of temperature. They are very strong, power to weight ratio really good, but in terms of temperature, no. So if you are at almost like orbital speed and then you go through atmosphere is like, bro, go get out of here. It just poofs it. Stainless steel is like, bro, I can fight, and most of the stainless steel can actually survive, and given the fact that you have a heat shield on that. So if any heat shield were on the right track, it's like, yeah. So not only you have very giant object going boom, and then it's creating such a big debris shower that is like, again, that's why I say, like, look at directly contrast this to space shuttle, and again you have the footage of that also. So this looks like a night and day difference. It almost looks like ISS itself re-entered the atmosphere. People are comparing this shot to ISS re-entry shot in the movie Earth. So Sandra Bullock, I think, was in that movie, something like that. So this was a big oops event. So what can we expect in the future? Well, reality is it is the biggest mess so far in all of the integrated flight tests. Like, this is big. This is so big that somebody had to pick up a phone and tell air traffic controller, it's like, bro, divert some traffic. That is not a phone call that you want to make. So something really serious, and debris cloud. And again, you're like, okay, the area was safe and all that. No, whenever you are going that up, and you are almost at orbit, that area becomes a yellow area. Launch area is a red area, meaning there will not be anything. But in yellow area, they will be like, okay, caution, stay in cautionary. That's why the planes had to be rediverted. So again, you can risk it, but nobody's gonna risk anything with planes, given the fact planes are having a lot of bad time recently. From Russia going boom boom with one plane, South Korea also going bam with another plane, and then a helicopter going bam. Trust me, nobody's taking a risk with planes anymore. And again, that's a good thing. I do want to live, because again, I have been using flight 2 times recently. So flat out, this was a big mess. And this is the first time people are actually realizing what they are actually asking. It's like, oh, we want a giant rocket. It's like, do you understand what that giant rocket means if something goes wrong? And let them be very clear. We're like, okay, we can make it as safe. There is no one that is smoking enough cocaine to justify that. Look at planes. We are working our ass off to make sure they are safe and reliable. But here's the deal. You know what? All aircrafts have that? Black boxes, which are giant orange boxes. Again, why do we put that? Because we know something will happen, because we are not gods. We are humans. We make oops event. In that oops event, having that data allows us to safeguard the next flight. And again, we have been very good. We have been working our ass off, and we have reached a point where oops events are only happening once or twice a year, and our flight capacity is growing exponentially. So it's like 1 or 2 oops event when you had 500 flights, 1 or 2 oops event when you have 10,000 flight. You see the point? Expecting that to happen on rocket, again, you are way too optimistic. And even assuming you did reach aircraft level thing, again, last few months has proven the fact that oops will still happen. So you really have to plan that out. It's like, how the heck you're going to handle it? How the heck you're going to align the orbit so nothing bad happens? Because again, you have dual failure priority. When you're going up and you're almost at orbit, second, when you are doing a re-entry burn and something bad happens. So it's a serious thing that we wanted a huge thing, you got the huge thing, now worry about it, kind of thing. So now SpaceX aim was doing 25 launches in year 2025. Now I think this will be hard to do, given the fact that according to FAA radio license, they have reached a point no earlier than 24 February. So likelihood is less. However, I do expect, let that be very clear, I do expect the people who are working on the booster, they could finish this puppy up. And worst case scenario, they're like, okay, we are running out of funds. Again, assuming that if they run out of funds, they can just convert this puppy into 200 ton to low Earth orbit. And that would be much easier. If they just yeet everything in Starship, it's like aerodynamic surfaces, yeet. Header tanks, yeet. Heat shields, yeet. The launch system, everything, you just yeet out of there. And again, no engines with wasteful sea level nozzles. All of them with giant vacuum nozzles. they can get some serious thrust. Right now, they can do a 200 tons to low Earth orbit without too much issue. Would that be useful? Well, that's exactly like Falcon 9. Now, of course, I do not expect everybody to be able to afford throwing away that much steel, but again, it's steel, not lithium titanium alloy. So it should be throw awayable, exactly like how Neutron rocket is doing. They are doing with carbon fiber, you're doing with stainless steel. And the Raptor engine. If you are mass producing a Raptor engine, price should not be too bad. So it is doable. That's like a Hail Mary attempt. If they want to salvage the program and they are running low on cash, they can do it. So that I can easily expect at the end of 2025. But Starship needs some more love. So this was my presentation on what the heck is going on with SpaceX Starship. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you are free. And as always, thanks for watching.